Alright, so today we're going to be talking about continuous growth, which is Euler, not Euler, Euler's number E. So to get us started, we're going to do an example. So let's say that we put $1 in a savings account, and let's say that it's at 100% interest for 1 year. Now, the thing that I didn't specify is how often this interest is compounded. So let's look at the different the different compound times and see how that affects how much money we're going to end up with. So we're going to change the n and we're going to put it into our our compound interest formula. So we're going to have 1 times 1 plus 1 over n raised to the n power. So if we just do this once a year, well, let's look at once, twice, 4 times. So monthly, weekly, and then let's hop down to daily, so 365. Now, if we do it once, well, that's just going to compound at the end of the year, so that's just going to give us $2. Now, if we do it twice, that means it's going to be 50% plus 50 more percent, so that's going to be 50 cents the first time, which would be 150, plus 75 cents the next time, which would give us 225. Now, let's go ahead and just keep going up until we get to 365, which seems like we should get a lot of money if we compound it daily, but you will be surprised. Oh, excuse me, so sorry. So after 4 times, it's going to be 2.4414. After 12, it's going to be 2.6130. Now, as you can see, we can already kind of tell that it's not increasing that much. So it only went up from a quarter and then less than 20 cents. And then still not very much after 12 months. So even when we bounce from 4 to 12, we still increase less than 20 cents. So if we look at compounding it every week, we can see that we barely crack 11 cents. And finally, at 365, we only end up with 2.7147. So here's the deal, is as we increase the number of times that we're compounding it, even though we're compounding more and more and more, our interest rate gets super, super small every time we compound. So when we do something continuously, here's what happens. Whoops. There we go. So if we have something growing at a continuous rate of 100%, then what happens is that it's actually going to get closer and closer to a specific number. So as we break it down an infinitesimal amount of times, so as n goes to infinity, that means that we're compounding it every moment of every day, it actually gets closer to 2.7181, which is called the number E, or Euler's number. This is called the natural number because a lot of things grow continuously like this, like plants, animals, things decay at that rate. So, if something grows or decays continuously, what we get is this new formula. So instead of using the compound interest formula like we had in the past, we're going to be using this formula. Which is also called the PERT formula. So it's A of t equals P times E raised to the RT. So what P is that's the principal, or the amount that we start with. What E is that's just the constant number, so it's 2.7181. Okay, and then r is the rate in decimal. Alright, and then t is the amount of time we're looking at. So usually this is in years, but it can be in months or days or whatever the problem talks about. So just a quick note, when we're talking about rate, sometimes things don't always grow at 100%. So maybe this one thing only grows at 20%. Well, if we want to look at what happens when something is continuously growing at a rate of 20%, then that's not going to be e, because e is 100%. It's going to be e to the 0.20 exponent. So that is where this formula comes from. Okay, so next we're going to look at some examples of using this guy.